Coordinates and graphs. A linear equation in one or two unknowns can be represented graphically by 1. Obtaining the coordinates of the points the line passes through. 3 points are appropriate to confirm the accurateness of the first 2 points. Plotting the coordinates on the Cartesian plane, that is the second step. The Cartesian plane is also called the XY plane. And 3. Joining the plotted points using a straight line to obtain the required straight line. The Cartesian or XY plane. The Cartesian plane has 2 axes, namely the x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. Both axes extend to negative and positive values. So that the Cartesian plane has 4 quadrants where points can be plotted as illustrated in the diagram. Points on a Cartesian plane are plotted as a pair of x and y values called coordinates, written x, y, where x value is red on the horizontal axis and y value is red on the vertical axis. For example, plot the following points on a Cartesian plane. 0, 0. So the first values are the x values, the second values are the y values in each case. So 0, 0 means both x and y are 0, 0, and that is the origin. So 1, that is the plotting of 1. In the second, we have 1, 2. The y value is 1, the x value is 1, the y value is 2. So where the 2 meet, 1, 2, that is the point 1, 2. X value is 1, y value is 2. Negative 1, 3. So the x value is negative 1 here, and the y value is 3. So we have negative 1, 3. So this point is the point negative 1, 3, where negative 1 meets with positive 3. We have negative 1, 2.5. Negative 1, let's make it negative 2, negative 2, or negative 2, negative 2.5. So the negative 2, this is negative 2, negative 2.5 is here, lies between negative 2 and 3. So where negative 2 meets with negative 2.5, the point marked with the x represents the coordinate negative 2, negative 2.5. And lastly, we have positive 3, negative 2. Where the 2 meet is positive 3, negative 2. Having known how to plot points on a Cartesian plane, we can now represent a linear equation graphically by following the 3 steps specified above. Example, represent the following lines graphically. We have 3x minus y is equal to minus 2, 2x minus 2y is equal to negative 4. We draw the table of values for each equation and we'll get 3x minus y is equal to negative 2. The table of values will be as follows. When x is 0, y will be 2. When x is 1, y will be 5. When x is 3, y will be positive 11. Similarly, we draw a table of values for the second equation. When x is 0, y will be 2. When x is 1, y will be 3. When x is negative 2, y will be 0. Representing this graphically, we obtain for the first equation, we plot the points on the table of values. We have the point 0, 2, and then we have the point 1, 5, should be somewhere here. 1, 5 will be somewhere there. And then we have the point 3, 11, which is the point that confirms the accurateness of the other 2 points. That is 3, 11. And then we join the 3 points using a straight line. And this will be the line representing the equation 3x minus y is equal to negative 2. Similarly, for the second equation, when x is 0, y is 2. When x is 1, y is positive 3. And when x is negative 2, y is 0. So we draw a straight line passing through the points. straight line passing through the points. So the second line, we label the equation, the line with its equation 2x minus 2y is equal to -4. So the two lines, the two graphs represent the two equations 3x minus y is equal to -2 and 2x minus 2y is equal to -4 respectively.